we'll be finding the sides and angles, and we will be making it very easy. All right, so what are we going to use? Finding the missing sides and angles, okay, of triangles. So we will be using what you call SOHCAHTOA. SOHCAHTOA, all right, to finding sides. So before we proceed with this, let's just review some certain things. That the sine of an angle is equal to the opposite side over its hypotenuse. The cosine of the angle is equal to the adjacent side over its hypotenuse, and the tan of an angle is equal to the opposite over the adjacent side. These you need to know. You need to be able to recall this very quickly. Okay, so we'll be looking at three particular problems here. So let me bring out the three diagrams. Consider a triangle, and this is going to be roughly, it's not exact. We have a triangle here. Okay, we have here an right angle. Call this 40 degrees. Call this maybe 14 units. I'm not going to put what unit it is. We have here this side. We have a next one here, and for this to work, this needs to be all right angles. That's one of the key things. Okay, and so let's call this maybe 35 degrees here. Maybe you are given this side here maybe 12. You don't know what's that side. Let me give it a different letter so you don't get confused by using the same letter. And then let's say we have another triangle here as this. Okay, so here we have 13, and maybe here we might have 48 degrees, and here we call Z. All right, so those are triangles which we will be working with. Okay, so we'll start with this one here. We look at the triangle and see what do we have. The knowns and unknowns. Key point: knowns and unknowns. What do you know? What you don't know? Or what are you looking for? Okay, so let's start. The angle that we have is opposite to the unknown on this side here. We don't know what's that angle, but we can figure it out. For right now, we know that we have 14, and this is the longest side, which is the hypotenuse. So this is the hypotenuse, and then what else do we have? Well, we don't have, well, we actually looking for this x, which is the opposite to this angle. Okay, so this is the opposite. Now let's see which one of the trig ratios works with opposite and hypotenuse given the angle that we are talking about. Opposite and hypotenuse. Opposite and hypotenuse. It is not this one here, it is not this one, but it is this one. So we'll be using the sine. So let's bring sine now. I put it right here. The sine of the angle is equals to the opposite over the hypotenuse. Okay, so we substitute for our values. All right, now I put this symbol here to show angle. All right, so we're gonna put now the sine of 40 degrees is equals to opposite, which we don't know. This is x over the hypotenuse, which is 14. We cross multiply and we end up with x is equals to 14 sine 40. Okay, now here is where you will need to be careful how you're stating your values. For example, when you're stating your values, make sure that you're using your scientific calculator, or if you know the values, then you can use them. The sine of 40 degrees will give us a particular value. So you may go and punch this 14 times sine 40 in your calculator and get a value. So let me just do that, and I'm going to be rounding off my values to 1 decimal point because I'm working with whole numbers here. So therefore, when I multiply this out, I end up with this sine 40, then that gives me equal times 14 I mean, and that gives me 8.999 0.0265 358. If I round this off to one decimal point, then this becomes 9.0. okay, and I need to stress that it's 1 dp so that the answer could be correct. Otherwise the answer would be wrong. Okay, let's go to the next one. For the second one, what is it that we have? So we have the second one, and we say, oh, we have this angle here, and the side which we know is here. So this is the adjacent side to the angle which we have, and this y, which is the unknown, is opposite to this angle, so we put here opposite. So which one of these works with opposite and adjacent? Opposite and adjacent will be tan, so we put here now tan angle is equals opposite and adjacent. Okay, substitute, now we end up with tan 35 is equals opposite, which we don't know, over the adjacent side, which is 12. Cross multiply, we end up with y equals 12 tan 35. So y equals, and we'll be rounding off that value, so we'll be multiplying it out by using our calculators. Okay, so we have now that tan 35 times 12 gives me 8.4, and this is rounded off to one decimal point. Okay, and so this is our solution. Very important that to stress to what decimal point you are putting your value. Reason is that you may use the same values in the next part of the problem. Let's go with the other one. Here we have the angle. This is adjacent to this angle, so therefore we put here adjacent, and this is opposite to the 90 degrees, and this is the hypotenuse. So we look at what uses adjacent and hypotenuse, which is cosine. So we put now cosine theta is equals adjacent over hypotenuse. The cosine of 48 degrees is equals adjacent, which is 13, and the hypotenuse, which is z, we don't know. Cross multiply, we end up with z cosine 48 degrees is equals to 13. Z equals 13 over cosine 48. Okay, now very important, you will find 13 and divide by cosine 48. Okay, so that's what we will need to do. So make sure that you use your brackets when you use your calculator with this. So you put now 13 divided by open bracket cosine 48 close bracket twice, and that gives us a value of 19.4, and that's to one decimal point, and that's our solution. So how do we go about in doing this? We look for the angle or what we have been given. All right, so here we have been given an angle and a side, and you can find the other side. Okay, so that's how you do this one.